Today, we will study about algebraic expansions. Last year, we studied about various algebraic operations and multiplication of polynomials using identities. This year, we will use some more identities to solve the complicated sums on expansions. What are identities? An algebraic identity is an equality that holds for any values of its variables. Since an identity holds for all values of its variables, it is possible to substitute instances of one side of the equality with the other side of the equality. Clever use of identities offers shortcuts to many problems by making the algebra easier to manipulate. Identities can be explained using geometrical figures. Observe the given square. Each side of the square has been divided into two parts, A and B. The area of the square will be the sum of the area of the blue square, that is A square, area of the red square, that is B square, and the area of the two rectangles AB. Hence, the area of the complete square is A plus B the whole square, which is equal to A square plus 2AB plus B square. Use the given links to understand the derivation of other identities. Basic algebraic identities that you studied are A plus B the whole square equal to A square plus 2AB plus B square. A minus B the whole square equal to A square minus 2AB plus B square. A plus B, A minus B is equal to A square minus B square. X plus A, X plus B, which is equal to X square plus A plus B bracket close X plus AB. We will be using some more identities such as X plus 1 upon X the whole square, X minus 1 upon X the whole square, X plus 1 upon X the whole square minus X minus 1 upon X the whole square, and X plus 1 upon X multiplied by X minus 1 upon X. Another commonly used identity is A plus B the whole square minus A minus B the whole square equal to 4AB. Consider the example given below. If A plus B is equal to 7 and AB is equal to 12, find A minus B. The easiest way is to apply this identity. Substituting the value of A plus B equal to 7 and AB equal to 12, we get 7 square minus A minus B the whole square is equal to 4 into 12. This implies that 49 minus 48 is equal to A minus B the whole square, or A minus B the whole square is equal to 1. Removing the square root on the left hand side and right hand side, we will get A minus B is equal to square root of 1, which is equal to plus or minus 1. The reason we take plus minus 1 is the square of a negative integer or the square of a positive integer is always positive. Look at the example. Expand 2x minus 3 the whole square. Using the identity A minus B the whole square, we will substitute 2x in place of A and 3 in place of B. Hence, we will get 2x minus 3 the whole square as 2x the whole square minus 2 multiplied by 2x multiplied by 3 plus 3 the whole square, which is 4x square minus 12x plus 9. Let's solve some sums from exercise 3a. 2a upon 5b minus 5b upon 2a the whole square. Before using the identity, identify the sign between the terms and then apply the identity. Here we'll use the identity a minus b the whole square equal to a square minus 2ab plus b square. 2a upon 5b is the first term. 5b upon 2a is the second term. Hence 2a minus 5b upon 5b minus 2a the whole square is equal to 2a upon 5b the whole square minus 2 multiplied by 2a upon 5b multiplied by 5b upon 2a plus 5b upon 2a the whole square. The result will be 4a square upon 25b square minus 2 plus 25b square upon 4a square. Note, 2a in the numerator, 2a in the denominator gets cancelled. Similarly, 5b in the numerator and 5b in the denominator also gets cancelled. Next sum, minus 2a minus 5b the whole square. Substitute the first and the second terms using brackets. When you use brackets, you don't make errors. Here the first term is minus 2a and the second term is plus 5b. Using the identity a minus b the whole square equal to a square minus 2ab plus b square, we get the answer as 4a square plus 20ab plus 25b square. Evaluate 10.2 the whole square without actual multiplication using identity. Split the given decimal in the most convenient form to apply the identity. Here 10.2 is split as 10 plus 0.2. So the first term is 10 and the second term is 0.2. Applying the identity a plus b the whole square equal to a square plus 2ab plus b square, we get 10 square plus 2 into 10 into 0.2 plus 0.2 the whole square. Adding all the values, we get the answer as 104.04. Evaluate the given sum using identity. Here, split the middle term to recognize the first and the second term. 4.8 becomes the first term and 0.2 becomes the second term. Hence, applying the identity a square plus 2ab plus b square equal to a plus b the whole square, 4.8 plus 0.2 which is equal to 5, square of 5 is 25. So the answer is 25. Given x square minus 8x plus 1 is equal to 0, find the value of x square plus 1 upon x square. Divide the given equation by x to get a familiar expression x plus 1 upon x on the left hand side. When we divide the given equation by x, we get x square upon x minus 8x upon x plus 1 upon x is equal to 0 upon x. That implies x minus 8 plus 1 upon x is equal to 0. Transposing 8 to the right hand side, we get x plus 1 upon x is equal to 8. Squaring on both the sides, x plus 1 upon x the whole square is equal to 8 square. Applying the identity a plus b the whole square is equal to a square plus 2ab plus b square, we get x square plus 2 plus 1 upon x square is equal to 64. Hence, x square plus 1 upon x square is equal to 64 minus 2 equal to 62. Given x raised to 4 plus 1 upon x raised to 4 is equal to 119, find the value of x square plus 1 upon x square and hence also find the value of x minus 1 upon x. This is a connected question. In first case, we will use the identity a plus b the whole square, which is equal to a square plus 2ab plus b square. Begin with x square plus 1 upon x square the whole square. Substituting the first and the second term, we get the answer x square plus 1 upon x square is equal to square root of 121. That implies x square plus 1 upon x square is equal to 11. Note, we cannot use the value as minus 11 since the sum of two squares is always positive. Consider the second case, x minus 1 upon x the whole square. Here we will use the identity a minus b the whole square equal to a square plus 2ab plus b square, which implies x square plus 1 upon x square minus 2. Substituting the value of x square minus 1 upon x square is equal to 11, which we got in case 1, we get the value of x minus 1 upon x the whole square equal to 9. Hence, taking the square roots on both the sides, we get x minus 1 upon x is equal to square root of 9, which means the final answer is x minus 1 upon x is equal to plus or minus 3. You have seen how we can solve the sums of expansion using square identities. Hope you will solve all the sums of exercise 3a. Thank you and take care.